Hello everyone, I am Dr. Sharon Samyukta, lecturer in physics, Maristella College, Vijayawada. I am here to present some of the basic concepts of solid state physics. This presentation covers introduction part, crystalline solids, amorphous solids, space lattice, basis and crystal structure, translation vectors and unit cell. Introduction. Solid state physics is a branch of condensed matter physics. It is the study of rigid matter or solids through methods such as quantum mechanics, crystallography, electromagnetism, and metallurgy. The study of solid state physics aims to interpret the macroscopic properties in terms of properties of microscopic particles of which solid is composed. Matter mainly exists in three states, likewise, solids in which atoms are tightly bound together. Solids hold definite shape and they have fixed volume. Liquids are the materials in which the atoms are loosely packed. It takes the shape of the container and they have fixed volume. Gases in which atoms are feebly packed. They take the shape of the container and the volume of the container. Coming to crystalline solids, a crystal or crystalline solid is a solid material whose constituents such as atoms, molecules, or ions are arranged in a highly ordered microscopic structure forming a crystal lattice that extends in all directions. Best examples are NaCl, diamond, quartz, etc. In this diagram, we can see particles are arranged in a regular manner, in a periodic manner. The example is table salt, which we use in our day-to-day life. Amorphous solids. An amorphous or non-crystalline solid is a solid that lacks the long-range order characteristic of a crystal. Atoms or molecules in these solids are arranged in irregular or in random manner. Examples are glass, plastic, soot, talcum powder, etc. These are the examples: glass, rubber. Glass is nothing but silica, SiO2. Amorphous materials like window glass have no long range order at all, so that they have no translation symmetry. This picture gives the description of arrangement of atoms. In a single crystal, atoms are arranged in a regular and periodic manner. In polycrystal, atoms are regular along the boundaries, within the boundaries. Again, in amorphous solids, atoms are irregular and not periodic. In polycrystal, we can observe that atoms are regular within certain regions across the boundaries. Space lattice. Space lattice is defined as an infinite array of points in space such that environment about each point is the same. Idealized geometrical concept. Always remember it is an imaginary concept where points are arranged in a three-dimensional array such a way that the environment about each point is safe. Each point in the space lattice is referred to lattice point. In the diagram, these are nothing but arrangements of points, and each point is considered as lattice point. Basis, or it is also called pattern. Each lattice point is associated with one or group of atoms. This group of atoms are called basis or pattern. The crystal structure is formed when a basis of atoms is attached identically to each lattice point. Here, this is a diagram in which we have a two-dimensional space lattice. Space lattice, again, it is nothing but arrangement of points. And basis. Basis is nothing but group of atoms. Each basis is associated with this lattice point. Altogether, we get crystal structure. Translation vectors. A lattice translation operation is defined by displacement of a crystal by a crystal translation vector. R is equal to N1A plus N2B, where N1 and N2 are integers whose values depend upon the location of lattice points with respect to origin. If you see the diagram here, ABCD or the nearest points, the distance between A and B is taken as A bar and the distance between A and C is taken as B bar. And these vectors A bar and B bar are termed as fundamental translation vectors or basis vectors or primitives. Unit cell. A unit cell is defined as smallest geometric figure which when repeated in 3 dimensions gives actual crystal structure. Unit cells are of two types: primitive cell or simple cell, in which lattice points are at the corners only. In a non-primitive cell, which is also called centered unit cell, which contains lattice points where no basis vectors meet, or a unit cell with more than one lattice point. To understand primitive cell and non-primitive cell in a much clearer way, we go to the following slide. In this diagram, we have two structures ABCD, which is a primitive cell, where this is called a primitive cell because the lattice points are only at the corners. Always remember, the number of atoms in a primitive cell is equal to 1 atom per unit cell. Implies, if you take ABCD, if you observe clearly, at the corner A, whole atom is not included into this primitive cell. Only 1/4 part of the atom is shared by the primitive cell. So totally we have 4 lattice points at the corners. Each lattice point contributes only 1/4 part. Therefore, 4 into 1/4 is equal to 1 atom per cell. Whereas in non-primitive cell, if you observe this diagram, P, Q or S, we have lattice points at the corners as well as one complete lattice point is present at the center. So the number of atoms in this particular non-primitive cell can be taken as calculation part. Each corner atom contributes 1/4 part So 4 into 1 by 4, that comes to 1, plus one complete atom is present at the center. Thereby, in this particular figure, the number of atoms in this non-primitive cell can be taken as 2 atoms per cell. So here only corner atoms contribute only 1 by 4th part because this is a two-dimensional structure. So altogether 4 atoms are there, 1 by 4, 1 by 4, 1 by 4 and 1 by 4 totally comes to 1 atom per cell. Here 1 by 4, 1 by 4, 1 by 4, 1 by 4 altogether we get 1 plus 1 complete atom is present at the center. Hope you have understood this. So here there are two important statements. One is every primitive cell is a unit cell. Every unit cell need not be a primitive cell. So a unit cell may be a primitive cell or may not be a primitive cell, implies it will be a non-primitive cell. Types of centered unit cell. We have simple cell that is represented by capital P. The other type of centered unit cells are base centered unit cell, body centered unit cell, face centered unit cell. Base centered unit cell is represented by C, body centered unit cell represented by I, and face centered unit cell is represented by F. Thank you for listening. Thank you.